Uh, it gave me zeros and ones only because the values in the edge in the alcoholism column only ranged from 0 to 1 because they were supposed to be Boolean values. I tried getting a joint plot for the age and diabetes. Joint plot contains three graphs, which the main one is a bivariate graph, which includes the x-axis, which is the independent variable, and the y-axis, which is the dependent variable. It also includes another graph on top of the bivariate, showing the distribution of the x variable. The box plot between age and diabetes, I try to show the skewness between the data between age and diabetes and the difference in the numerical data, but we had only zeros and ones. I used the group by function to give me the exact number of patients with certain characteristics. In this case, I used it to find the exact number of patients according to gender, the exact number of patients who had alcoholism and who did not have. I used the group by to find the exact number of patients who did not have diabetes and those who did. I also used the group by function to get the number of handicapped people. But in this set, we had five different types. So I did not know which type of handicap is if they had different types of handicap. Maybe one was blind, maybe one was physically handicapped. That I don't know from the data we have been given. The group by function to show the number of people who actually attended their appointments and those who did not. The number of people who received messages and those who did not. I used the group by function also to know the number of patients from each neighborhood, which is depicted in this output. For example, for Eriopoto had eight patients. Antonio Honorio had 271 patients. So that was all I did with Python. Then we went ahead to Tableau, where I used true or false instead of the zeros and ones. I changed the zeros to be false and ones to be true, and then I replaced them and imported them onto Tableau as a text file. So in Tableau, uh, I had some analysis questions which we were asked to come up with. So I came up with 9 questions, which I analyzed and presented them on the Tableau. Number one was which neighborhood had the highest number of alcoholic patients, which gender had the greatest number of hypertension patients, compare the age of patients with alcoholism, what is the age of the oldest patient, which are the top 20 neighborhoods with female diabetes patients, which neighborhood has the highest number of appointments, what number of patients received an SMS and did not show, what is the number of no-show patients per day for every neighborhood, and which neighborhood has a hypertension patients with the highest attendance. So those were the 9 questions they came up with and presented them on the Tableau. So here we have a comparison of the hypertension in genders. So I imported the data for gender and colored. We used it as a marker for colors. The count for the number of hypertension patients. You can see from the worksheet we have 6,462 male patients have hypertension, while 15,337 patients, female patients, have hypertension. I also use the filter to only show patients who have their hypertension column to be true only. That means the patients included in this analysis only have hypertension. The other worksheet was the ages as affected by alcoholism. From this we can see that the greatest number of patients falls in between 63 years and 40 and 44 years. 63 years, 178 patients age 63 are affected by alcoholism, while 174 patients aged 44 are affected by alcoholism. I used the edit colors to give me a red, green, gold diverging color to represent the ages. I also used the alcoholism filter to only show the patients that have issues with alcoholism only. Here, I used I was analyzing the top 20 neighborhoods with the female diabetes patients, and this graph shows the top 20 neighborhoods arranged descending from the highest to the lowest. The female patients, I used a filter to give me the patients with only diabetes and the female patients, um, which came up with 20, 20 neighborhoods with the highest number of female patients with diabetes. Here we can see the resistencia with 219 patients. And here we can see Jabor with only 18 female patients with the diabetes. There's a legend here or a key here to show the neighborhood as depicted by their colors. I also used the Tableau to find the neighborhoods with the highest number of booked appointments or scheduled appointments. The highest was Jardim Kaburi with 7,717 patients. These are only scheduled appointments, not attended appointments. I also used the Tableau to show the number of patients who received an SMS and were a no-show. This table shows the filter which was used to show that they did not show, that is true, and they received an SMS which is also true. The highest neighborhood with the highest number of patients who did not show and received an SMS is Maria Optis with 641 patients. And the last neighborhood who is Jabur with 217 patients who received an SMS and did not show. I used the Tableau to find the oldest patient the institution is dealing with, and the oldest patient is 115 years. This line graph shows the age of patients that did not show up. The highest number will be said 291 female patients aged 30 did not show up, and the highest number of male patients that did not show up is 228 male patients aged 9 did not show up. I also created a dashboard of the data I analyzed to come up with something like this. Yeah, that gives us an accurate data in one page. Yeah, I think that's all.
Okay,
Thank you.
thank you so much, Alois Brian. I think we have our colleagues here. Just comments to start from my side before I invite Joseph and maybe with Fred briefly, because we have other students who are supposed to present. The next is John, but I just want to come on the business side, not the technical side today. One thing that I have noted when you are presenting, despite the fact that you have showed a good mastery of the curriculum and so on, suppose you are presenting to the board, you are supposed to state like your data was from this period to this period, uh, um, and also where it was obtained and so on before you start. Yes, again, it was on academic side, we are looking forward to see the mastery of it. But suppose now you are presenting to the board, just this is an advice now. You just go straight to the dashboard where you explain everything. But I'm very impressed with the mastery that you have showed in the presentation. However, also, you started on a low note, a bit tense. You need to be composed. We will be sharing the recording for you to follow later. Thank you so much. Maybe Gitau, do you have anything for Alois before
Yeah,
John?
so for me, my only comment is on what you've said, Xavier. So, Alois, anytime you want to present your results, so just on the code part, just present like a brief theory of what you did. So just mention things like I checked for duplicate values, did away with the duplicate values, checked for missing values, on the dashboard. I think everything is okay, so everything looks fine. So this is a wonderful job. So anytime you are presenting, just like have a brief description of what you did on the code side and explain more on the dashboard, since that's where we need information. Yeah, so that's all.
Okay, thank you so much. Fred, do you have anything to say?
From my side, I don't think I have anything to say because I can see from the presentation that Alois has made, it actually shows there is a mastery of the content. So mine is just to encourage him maybe to perfect on it so that he can become an expert. But so far, he has done a wonderful work. So congrats, Alois, and continue with the same spirit. Thank you.
Thank you. Thank you.
Okay, thank you. Maureen she's on transit. She cannot comment now, but we will again come up with our comments later as we are presenting the results. So thank you, Alois. You can have a wonderful weekend. You can leave so that we can allow John. And sorry for the rest of our colleagues, is that it is taking quite some time, but I think we are also learning. Thank you, Alois. You can stop presenting. You can still stay to follow others for the purpose of learning. But I want now to invite John. Maybe on my side, John, my name is Xavier Aluku. I hope we interacted most of the time. However, we have not met yet physically. I'm here with my colleague Joseph Gitau. He's a machine learning engineer. Then also we have Fred Mirimo, a data scientist also. And of course, Maureen, you know her better. So welcome, John. If you're in a position to share your screen, you can proceed.
Thank you, thank you. I hope I'm audible enough. And good morning,
Yes.
everyone.
Good morning.
Yeah, thank you very much. I'll first of all do a small report. This is just a brief. I hope you can see my window.
Yes, yes.
Yes, thank you. First, I would want to first of all apologize. Actually, the assignment coincided with a very busy week for me, and I had actually tried to reach to Ruben, but then again he gave me a different information. So I really rushed to do this project, and but I believe I may have captured the necessary area of interest. So my name is John, and this is a brief summary of what I did. I intend to take probably a bit of a short time. I have another engagement around 11, so I will briefly go through the report. So as per the project report, we had been requested to first do an introduction. So I'll briefly go through the introduction and the report I did, and then I can briefly rush through the Tableau and Python, which I used in the project. So the analysis had a data set that was from Brazil on with respect to medical appointments. The sample database dataset used was from a Brazil hospital with a total of 110,527,000 appointments and a total of 14 fields. You'll be able to see that from where the information had been collected from the patient, and the period the same was done is between November 2015 and June 2016. The total number of patients were 62,294, where 40,043 were from female gender, representing 64% of the dataset, while the remaining 22,551 were male, representing that 6% of the sample, respectively. Then there was also a link. This was just for our own information. There was an area where there was data from those who are under scholarship, and we realized the sample had a data set covering scholarship where it was being offered by Bolsa Familia, which is a social welfare program of the government of Brazil, providing financial aid to the poor Brazilian families, where families had to ensure that the children attend to schools and get vaccinated. So that was my brief introduction with respect to the data. Of course, this was after analyzing the data and getting some of these figures and insights. Then from there, I did a sample of 7 questions. One was to establish how many appointments were done per gender. 2, which one had the highest number of appointments. 3, how many patients had done the appointments per gender. Based on the analysis, which gender is likely to miss appointment. 5, amongst the 4 medical conditions, which had the highest number of patients. Then 6, how many patients showed up on the appointments per gender. And then 7, which day and month had the most scheduled appointment. So those were sample questions that I came up with. But then I combined almost all in these under findings. So as Joseph have just mentioned, I also pictured the whole thing that you'd be doing this probably to a board or such or management. So this was just a brief report of what I would otherwise present. So on the findings, the analysis focused on the patient's behavior with respect to how they honor their medical appointment and the disparities that exist between the two genders, that is male and female, as well as other applicable parameters. These will be with respect to the other fields that had been considered in the dataset. So first, on appointment, most of them were scheduled between April and May 2016, where that May had the most scheduled appointment with a total of 4,238, and the appointment had 65%, representing 71,840, being from female, while 35%, which is equivalent to 38,687, were male. And you can be able to see a pictorial representation of the same. This is using Python. Then two, from the analysis, 80% of the appointment, which was equivalent to 88,208, did not show up for their respective appointment. I think this was the main key area of interest to see how people respond to appointment. And again, that is a representation of the same. From the analysis, we are able to see the several conditions. So we are saying from the medical conditions considered in the sample data, we had alcoholism, hypertension, diabetes, and handicap. Hypertension had the highest number of patients, that is 21,801, representing 35%. Diabetes had 7,943, alcoholism 3,360, and handicap 2,459, respectively. And again, that is a graphical representation of the same. These are bar plots using the Python. That's just the same, a continuation of the same. We have alcoholism and then handicap. Then with respect to age, the mean age of the patient was at 7 years, while the maximum age from the dataset was a patient with 115 years. And then again, a distribution of the same using the Python is there. You can be able to see. You can see where we are talking of our mean being that 7 years, and you can see the concentration of our distribution is between close to 20 and slightly before 60 years. That is the distribution of our age. And we had one outlier, which would be the 115 years. Then from there, we are also saying we had, with respect to those who had scholarship, 9.82%, which is equivalent to 10,861, had scholarship, with 82% of them, that is 8,853, being from female and 2,008 being from male. So in a nutshell, that is a brief description of the report or of the analysis. And then we are saying from this, there are three broad conclusions that can be derived from the analysis. And from the analysis, following conclusions can be made with respect to patients missing the medical appointment. One, most patients, that is 80%, did not show up for their appointment. We've been able to see that. Then two, females are more likely to seek medical attention and honor appointments as opposed to men. Then three, we have hypertension is more pronounced in females than it is to men, while alcoholism is more pronounced to men than females. So that is a brief summary report of the project and what I was able to compile. Allow me to briefly now share just what I had been able to do using the W and Python. So I'll
Well
start off
said.
with the Python.
Sorry for that. I was telling Muteti to mute a bit. You will present. Thank you. Just proceed, John.
Okay, okay. Okay, thank you. I will start off with Python. So first, I imported the important libraries with respect to this analysis. That would be NumPy, Pandas, Matplotlib, .pyplot, Seaborn, and again for the purpose of the doing the graphs. So first was to import the dataset, then named as df, that is data frame, using the pd.read function. I imported the dataset. Then first I did the head function to give the first 5 rows of the dataset, as you can see. Then I also did the df.info to give the
Sorry, John.
information with respect to the
John,
dataset. Yes, yes.
I think
Yes,
I
yes.
can't see your screen for now. I don't know if it is on my side only. You can reshare it once more. I don't know. Gitau, you can confirm if you can see John's screen.
Are you able to see it now?
Y- yes. Yeah. It's okay now. Thank
It has come up, eh?
you. Yes.
Okay, thank you. As I was saying, I can briefly just go through. So first was to import the libraries, which I did, the NumPy, Pandas, Matplot, and Seaborn. Then I imported the dataset. Then I did the head function to show the first 5 rows. I did the info function to give the information with respect to the dataset. Then the other one I did the shape function. This is where I was able to see the 110, 527 total number of LOs and a total of 14 fields. Then I did the print the columns. These are the column headers, and you can see all of them there. Then the other one was describe function. So from here you can see the count, mean, standard deviation, minimum, and the quartiles as well as the maximum. So from here you can be able to see this is the total number of the data that rows that we are dealing with. The average mean or the mean age being 37. Then we had the standard deviation. We had a minimum of -1, which was a bit unrealistic. Then from there, you can see the maximum age, which is 115, and you have been able to see the same. Then from there, I did some plots, some count plot. First was the count plot for the no-show. So these are just the, the plots, but I've also obtained the respective figures for the same. So I did the count plot for the no-show, count plot for the hypertension, again count
Hello,
plot
John. Your
for
screen is not
diabetes.
visible.
Yes, yes.
Check your
I
screen.
don't know what is
It's
happening.
not
I
visible.
think
Yeah, so everything is okay now. You
is
can
it back?
proceed. Yeah, it's back.
Yeah, I don't know why it is back. Eh? So sorry, I'm saying I did some several count plots. So first was with respect to the no-show. Then the other one was with respect to the medical conditions that are captured in this dataset. First was with respect to hypertension, as you can see. The other one was with respect to diabetes. The other one was with respect to alcoholism. And then count plot for gender. You can see the distribution of the data set with respect to gender. So we had more female than male. Then bar plot appointments, bar plot on appointment day and the patient ID. Okay, this was just exploring the data and trying to understand the data.
It
again, it has.
John, you can reshare again. I don't know why it is dropping.
I don't know why it is really dropping because yeah, I believe it's back.
Yeah, it is back. Just proceed and try to increase the speed because of time.
Yeah, so I was saying yeah, sure.
Okay, thank you.
So as I'm saying, I did some BAPROT. So you can see the BAPROT on appointment day and patient ID. Then I joined prot on appointment and patient ID. This was just exploration of exploring the data. Then I also did another head function, the tail, then count prot on scholarship with respect to scholarship, the distribution of patients by gender. Again, BAPROT with respect to gender and patient ID, the distribution of appointment ID, distribution of age. This is where I picked that graph for age. Then account prot on gender again. Another count prot based on appointment day, where I even color coded them to purple. Then this was now obtaining the respective values or figures for the graph. So I did the value count for based on gender for the no show. Then sorry, it has dropped again.
Yes, yes. But you are almost done, I see.
Yeah, sure. Yeah, so again, this is on a value count for the no show with respect to hypertension. Again, this is the value count with respect to diabetes, alcoholism, handicap, and then account prot with respect to handicap. With respect to scholarship, again, you can see the same. Then I also tried to do a group by gender for all the fields. Then the distribution of the gender with respect to hypertension. So that was as much with respect to Python. And then briefly, I will look at the dashboard for Tableau. So I'll go straight to the dashboard. So I believe you can see the dashboard. So on this, I just picked probably the main key area of interest. One was with respect to the female, with respect to the female, with respect to the number of patients. Again, most of them were female, and with respect to those showing up for the appointment, again, you can see most of them did not show up for the appointment. So this was just a trending with respect to the days of appointment, and you can see the trend. And then with respect to the scheduled days of appointment, and this is where we are able to pick that the day with the most scheduled appointment was 3rd May 2016, being the peak for this particular trend. And again, using this representation, you can see again, this is the highest number for that particular month. So the month with the highest number of scheduled appointment was May 2016. Then with the respect to the
Again,
four
you can
areas
hello.
of medical
Sorry.
condition, I don't know whether it is.
You have dropped, so you can reshare once more as you conclude because of time.
It's back.
Yeah.
Yeah, sure. So again, I'm saying with respect to the four medical conditions, you can see I was able to again split the same with respect to those who showed up and those who did not show up. So you can see with respect to hypertension, this is the representation. Again, the female were many, and again, most of them also for the respective category did not show up. With respect to alcoholism, you can see most of them, alcoholism is more in male, but again, quite a number of them again did not show up. With respect to diabetes, we have the female being most of them, and again, quite a number did not show up. For the handicap by gender, again, that's the distribution. So that, in a nutshell, is my brief presentation of the project, and I believe I captured the most key areas of interest. So thank you.
Thank you so much, John. I think just to start from my side, I love the presentation, especially you are able to give us the source of data, the time period, the methodologies used, the findings, and the conclusions. And also in terms of composure, I think you are so much composed. Maybe just one comment. I hope now on the your first presentation, I hope if you are going to the board, of course, with W, you can use the dashboard, which was uh, well done with some images, also all the slices, if I'm not wrong. But now,
Yeah, sure.
when it comes to the first presentation, I hope if you are required to present using maybe PowerPoint, you put in a very good slides and so on. So that is what I can comment, but I'm very happy on what you have done. Maybe Gitao.
Yes, for me, I can comment and say, like, the presentation was great, the communication was good. Then also, your dashboard structure was kind of unique. So everything that you did was great. So I have nothing else to add. So Xavier has added some other comments. So I think maybe Fred can come in and comment too.
Okay, thank you. Fred, do you have anything to say before Ernest comes in?
Uh, Actually, that's a nice presentation from John. So from the way he's presenting, describing the source of the data set, I think everything it just flows fine. So I didn't pick anything to critique about his work. Just let him continue keeping up with that spirit and keep practicing more. Thank you.
Okay, thank you so much, John. We will, of course, respond with some comments by email. Thank you. You are allowed now to maybe give your comments as you leave so that Ernest comes in. And we are sorry for the rest of the team due to the delays. Yes, John?
Yes, yes. Thank you, Xavier. I think first I would really appreciate the training. We have really learned a lot. But again, I've noted, especially for us, probably who are also working, it's a bit tricky for us with respect to practicing. I was actually in the field when we were given the assignment, but all in all, I believe once we keep practicing, we'll be able to perfect it. So thank you very much.
Okay, thank you. Thank you. Have a nice weekend.
Thank you. You too.
Okay, Ernest, you can come. And sorry, Kieti and Matano, for the delays. It is taking quite some time, but I hope you are all learning. Yes, Ernest, welcome.
Good morning, everyone. My name is Ernest. I want to give a presentation for the project that we're given for the Brazil data. Let me just present it just a minute. Could you guys confirm if you're
Yes, I can see from my end.
Okay, so it's a project, it's a medical appointment data set that we're given, and it included over 100,000 appointments from Brazil. The data was mainly created in the study of predicting and seeing what factors would affect the patients who would miss their appointments. And from the data, we have seen that it contains various demographic data, and it also includes the patients if they include if they received an SMS or not. So this is my research questions that I would have done. I wanted to see what proportion of male and female was there in the total data set, and also the patients who visited the scheduled appointment, the diseases that most people were suffering from, factors that led to the patient not showing up for their scheduled appointment. The disease is likely to occur as per age groups and how likely the people who received the SMS were to show up for their appointment. We can also see the frequency, day and time they showed up for the appointment. So here I performed some data wrangling, going through the data. And I just went to see the data types. As you can see from the different data, I checked if there was any duplicated data or any null data, which I didn't find any. Here we can see I've concluded that the data has set as 0 duplicate and null values. Here I dropped the appointment ID and patient ID and just a minute. So we can see that I checked on all the data, it was okay, and I was moving forward to see the type of data we had and the number of patients. So here I checked on the data that everything was okay. I've converted it. All you can see it's in underscore. There's no capital letters cross. And then here I changing the column to no show, just changing the values accordingly. Since I understood when it said no show, yes, those are the patients who didn't show up at the appointment, and the no show no are the patients who did not show up at the appointment. I changed the data appropriately. Here we can see I tried getting the time of and hour the patients were coming for the appointment, and here I have displayed the time and hour the patients would come in for the appointment. And here I was getting the monthly appointment and the appointment date and the year that it occurred. So you can see I have displayed here for just a sample of the data. You can see it occurred in 2016 and the appointment month was 4th. And then I got the schedules from the month. And then I dropped the schedule day and appointment day since I had gathered all the data. Now I started exploring the data. So I did a small presentation here to just see if the data was okay according to the appointment year, the schedule month, and the time and hour was all in place. So I did a plotting here, of which I see the distribution of age and the frequency that people made their appointment in order to come to the appointment. Here across, we can see from 0, there's a lot of appointment increases as the age goes on. And then I checked if I had any errors in the data. I saw that I had a negative number in the age. I dropped it because I thought that was an error. And then we can see the proportion of male and female that occurred. So we can see that show yes, I set it to yes, and show no, I set it to no. We can see, according to this data, 80% of male and female showed up for their scheduled appointment. And here is just, I wanted to show in a graph, so I calculated, and we can see here as per the graph, the people who showed up for the appointment from this green graph, from this green bar. You can see it's 80% of the people showed up. And here's the calculations that I did. So now we go on ahead to the diseases that most people are suffering from. And we can see from this graph that I plotted the diseases most people are suffering from is hypertension, followed by diabetes, alcoholism, and handicap at the end. And I wanted to also see that distribution that hypertension occurred according to ages, and therefore plotted a graph here, a bar chart that included the number of people and the ages on the other side. So we can see that most people between the age 40 and 80 are the ones who suffered most from hypertension. And then I went ahead to check on the frequent times that people made an appointment during the day. And we can see from this bar chart that the frequency of the appointment was made mostly at 10 a.m., the time of the day. And it went on up to 8 p.m. at night, which you can see here. But most of the appointment occurred between 6 a.m. and 5 p.m. I went ahead to check on the diseases that are likely to occur according to age groups. I checked on the data and I set it according to 4 different categories. And we can see here this child, young, and middle age, and senior. And then I went ahead to plot a graph. And we can see from this presentation that there's, according to the senior, there's the highest group occurring with hypertension, and then followed by diabetes, alcoholism, and handicap. This is according to the senior. And then the middle age, we can also see the same trend, except we can see here alcoholism is going higher than diabetes. And then among the young group, we can see there's a higher chance of handicap, and hypertension is also at the same, almost at the same, though hypertension is lower than the handicap. And the child group, we can only see that handicap are only occurring there. So I went ahead to check if the patients who had received an SMS are likely to attend the appointment or not. And then we can see here from the bar chart that those who did not receive SMS and those who received SMS, this is the people who attended for the appointment. We can see that 68% of the patients who did not receive SMS, this figure here, that they already attended the appointment even though they did not receive the SMS. So I made a conclusion on the data. According to the proportion of gender, we saw that a larger group of females made appointments than male. And I went ahead to say that men's lives are less healthy and shorter than women. And this health disparity in part makes women better caring themselves other than men. And to the part where the proportion of people who showed up for the appointment. And we can see that from the data, 80% of the people did show up for the appointment and 20% did not show up. So regardless of the data, we can see that most of the people are taking care of their health and showing up for the appointment. And then I had to check from the diseases that the people are suffering. And across the board, we can see that hypertension was ranking the highest, both the female and the male gender, followed by diabetes, alcoholism, and handicap, in that order. And we also see that there were some differences, as we have seen from the bar chart, that at some point handicap was coming higher, like in children. And we can see from the young, we can see that there was higher cases of handicap also. So I went ahead to analyze the time of visiting the appointment, which was, you can see most of it occurred between 6 a.m. and 5 a.m., which was during the early hours of the day. And a large group of patients, most of the patients attended their appointments at 10 a.m. And then the diseases according to age, I had set 4 different age groups. The one I had shown it, the child, the adult, the senior, where we had seen the senior had the highest proportion of hypertension and diabetes. The child group has fewer cases of hypertension, diabetes, and alcoholism. and having handicap being the highest. The infant had only cases of handicap. And if we go to the scheduled appointment, according to the SMS received, we had seen that most of the patients who had not received the SMS had showed up for their appointment, which we saw that it was 68% of the total number of patients who had scheduled their appointments. And then if we see the important factors are people showing up for their appointment, we see that there's a few factors that had hindered them from attending the appointments. Some of them was the age and the type of diseases and the SMS that we had sent. So we see that SMS is not a good parameter for the patient showing up, since more of the patients who had not received the SMS showed up for the appointment. I had gone ahead and gone through some limitations. So according to this data set, I had seen a 3-month information, which we can't tell. It's a limited short period of time. We can't tell from the other months what had occurred. And then we can see from the data set, we weren't given the patient symptoms and the reason for appointment, which would have been better for predicting the appointment. And see from the data set here that we were not notified the distance between the patient and the hospital where they are going to attend their appointment. Therefore, it hinders some capabilities. And then we can see that we had some unrealistic data, like the negative data we had from the data above we had removed, and therefore that is unrealistic to this data. That is my presentation part on this, and then I can go ahead to present on Tableau. If you guys can confirm if you're seeing my screen.
Yes, I can.
So here I had gone ahead to say the data showing the attendance of appointment and how they are affected. According to the data given, we can see that the number of people who attended here is those who attended and those who did not attend. The ones who attended, most of them had hypertension, which we find it as a major factor in making people make their appointments. And then here we can see the number of people attending per day for a week. That's the sample of the data. We can see that most people make their appointments on Tuesdays, according to this data. And on weekends, the appointments slow down, and we only see that most of them are made on weekdays. And then I went to SMS sent by district or city. We can see that this neighborhood had the highest number of SMS sent, and we can see that most of them had attended. This here, we can see that most of the people who received the SMS attended, and it goes across like that. And here we can also see that some people did not attend a certain percentage. Then I went to create diseases according to gender. You can see that the female gender here has a higher rate of hypertension than the male gender. And we can see that the male gender has a higher rate of alcoholism than the female gender, which is also the same for diabetes being higher in females rather than males. And here we can see the proportion of the people who are given a scholarship. The male gender, you can see it has 2008. That's the number of the people who are given scholarship under the male gender, and the female were 8,853. Therefore, most people were given scholarship, the female. And then here I went to draw some conclusions where I said, irrespective of gender, 80% of the people visit their scheduled appointments, and you can see people who suffer from hypertension. As we can see at this data, those who attended have higher rate of hypertension cases. And hypertension is mostly observed as the highest, followed by diabetes, alcoholism, and handicap. This is generally across the data. And we can see that Tuesday has the highest number of patients who attended here. We can see that most of them who attended had hypertension, and even we can see that the diabetes had a higher number across the board. So we can see that most of the patients did not attend their appointments on weekends. Most of the appointments was made on weekdays. And you can see more female patients suffer from hypertension. You can see from this bar chart here, the female is higher than the male. And we can see that more male suffer from alcohol than female. As you can see here, this is higher and the female is lower. And you can see that scholarship does not affect those who attend or not. We can say that is not a considering factor if a person attends or not attends. That is the end of my presentation.
Okay, thank you so much, Ernest. I think just to start to give my comments is that first of all, I like the composure. I like also that you have also given where uh, a bit of description about the data. I like the W part of it, and also the conclusion were very detailed. And for any person, maybe let us say the board members and so on, they are in a position to understand the whole concept. I think I don't have any reservations for your presentation, and master of the content was great. Maybe Gitau, you can come in, and then Fred.
Okay, thank you, Xavier. So, Ernest, the presentation was great. So, your Python code was structured in a way that is understandable. So, you have the data explanation part, exploring of the data, then the creation of the visualizations, which is great, plus the conclusion from what you find in the code. Then also the Tableau dashboard was looking great too, and your presentation was well structured. So I guess that's all that I can comment from my side for now. Fred.
Okay, thank you, Gitau, for the comment. So I don't have any reservation with regards to Ernest's presentation because he has actually followed all the necessary steps that are necessary in when doing data analysis. So I've seen he has done some bit of description of the data set. He has done some exploratory data analysis. He has looked at the distribution of data also according to the gender and so on. So I think the whole concept of the description of the data and how it is structured, I think it was well captured. And also on the W part, it was awesome. That dashboard was looking a bit professional, which is actually good when you are presenting to the senior management of the company. So also the conclusions were comprehensive, so which can make any lay person can understand. So for Ernest, actually, that's good and wonderful work. So keep on with the same spirit and also continue practicing more to own the expertise. Thank you so much.
Okay, thank you, Fred. Maybe Ernest, we can give you to say something as you leave so that the next speaker can come in. And again, apologies for our colleagues. It is taking quite some time, but we are learning a lot. Yes, Ernest?
I'm very thankful for this. I have learned a lot so far where I've gotten with the data science. And what I can just say that I'm very thankful. That's all I can say.
Okay, thank you, Ernest. Data leave of great, thank you so much. The next is Brenda Kwamboka. And sorry, Matano, Kieti, and Pascal. We are a bit sorry that it's taking quite some time. I don't know if Brenda is here. She's not. I think she dropped off. Maybe Muteti, are you ready on your side?
Yeah, I'm ready.
Okay, you can proceed.
Let me share my.
Yes, you can proceed. I can see your screen.
Okay. On the Python part, I first check the overview of the data set. Yeah, and after that, I went and imported the necessary libraries, which are the numpys, the pandas, the matplotlib, and the seaborn. After that, I loaded the data, checked the head where it gave me the first five rows. Then I checked the info, which gave me the number of columns and also the number of rows, and also check the shape. It also give me the number of rows and columns. I described the data, whereby I found in the edge there's a negative, which looks which is I think it's an outlier. Okay, then I just came again after checking the edge and seeing the outlier. I came and checked the value count of the edge so that I can see if there's really an outlier. And I found there's an outlier which is -1, which as I think it was recorded there was a single patient who was recorded with a -1 edge. After that, I checked if there is some null components in the data, and I found none. I then gave a brief introduction. After loading this data, we saw several properties. As you can see, the data set has 110,527 rows and 14 columns, which provide deep information on the data. The data set has no values, but is likely as an outlier on the edge column, since we cannot have a negative edge number. The outlier needs to be cleansed while doing data wrangling. The maximum age for the patient is 115 years, while the minimum age is -1 year, which is likely an outlier. The average age for the patient is 37 years. After that, I went to data wrangling and understanding the data. After checking the data set, I found out that there's an outlier. So I identified the row so that I can make it easier to drop it. Then the next step, I dropped it. Yeah. So that I looked for the categorical values in the data, and I targeted the neighborhood column so that I can check the unique values. I found 81 unique values. After that, I went to the exploratory data analysis. So I just took a sample so that it can guide me. And then I structured around 11 questions so that they can lead me and help me analyze the data. Well, for ease of analyzation, I went column by column, whereby I started from the left to right. Where I analyzed from left to right. My first question was which gender record the highest number of patients, whereby I found out that whereby I ran a code and found out that the females are more than the males in terms of count. Where I found out that the female gender is more than the males. with I think an 80% and the males at 20%. Then I came and visualized it using backplot, whereby according to the backplot, you can see that we recorded more patients of the female gender than the male gender. Then my second question was how many patients did not show up for the appointments, whereby I found out that 8807, 8800, 88,207 patients showed up, while 22,319 did not show up. I then visualized it within a bar plot, whereby I explained there below about the around 88,207 patients showed up for the appointments, while 22,319 patients did not show up. My next question was which gender has a tendency of not showing up for the appointments, whereby I grouped by the gender, targeted the no-show column, whereby I went gender by gender, whereby for the females, those who showed up for the appointment, they were 57,245, and for the males who showed up, they are 3,962. I explained below. As we can see, the female gender's more tendency of not showing up for the appointment is the R 14,594 in number, compared to the male gender one 7,725 in number. In terms of showing up, females have more show ups than the males, with 57,245 females compared to 30,962 males. I started the next question, which read how many patients have hypertension and how many hypertension means appointments. Those who have hypertension, in terms of those who have hypertension, in terms of the patients, they are 21,801, and those without are around 88,725. And I visualized it using a bar plot. Then I went next and checked how many hypertension patients missed appointments, and I observed that there are the 3,772 patients who not show up for appointments who have hypertension, and 18,029 hypertension patients who showed up for appointments. I saw the next question, which read how many patients are diabetic and how many diabetic patients miss appointments. As observed, I saw that the count of the diabetic patients who have a diabetic patient are around 7,943, while those without diabetes are 102,583. Those who miss appointments and are diabetic are 1,430, while those who show up are 6,513. I then started the next question, which was how many patients are alcoholics and how many alcoholics show up for appointments. The number of alcoholics are 3,360. The non-alcoholics are 107,166 in number. The alcoholics who do not show up for the appointments are 677 patients, while 2,683 show up. I saw the next question, which is how many patients are uncut and how many uncut patients miss appointments. Okay. I checked and found the uncut patients are 2,241 in number, and those which are who are not uncut are 108, 108, 100, 200, 1,285 patients. The handicapped who missed the appointments are 407 in number, while 11,834 show up for the appointments. The next question structured was how many patients have scholarships and how many patients with scholarship miss appointments. Around 10,861 patients have scholarships, while 99,665 patients do not have scholarships. For those patients with a scholarship, the appointments are 2,578 in number, while 8,283 patients with scholarship show up for their appointments. The next question I started was what's the age of most patients and which age records the highest number of no-shows? The age between 0 and 1 years records the highest number of patients with 3,539, while age 99 years records the lowest number with 1 patient. I visualize this column with a scatter plot. Yeah. Then I went next and analyzed the age with the highest number of no-shows, and then observed that age between 0 and 1 has the highest number of no-shows with 639 patients, while ages 96 and 98 has the lowest number of no-shows. Then sorry, the next question, which is which neighborhood records the highest number of patients and which neighborhood is a victim of no-shows in appointments. Observe that 717 patients come from the Jadim Kaburi neighborhood, while the least, which is 1 patient, comes from the Pakui industry. I then looked at the neighborhood with more no-shows, where I found out that the Jadim Kaburi neighborhood has the highest number of no-shows, with 1,465 patients, while Arapoto has the lowest number of no-shows, with 1 patient no show up. Then try the next question. Which appointment day records the highest number of patients and which appointment days records the most no-shows? I observed that the appointment day, the 6th day of June 2016, has the highest patient count with 4,691 patients, while appointment day, the 14th day of May 2016, has the least patient count with 9 patients. I then checked which appointment days records the most notice, whereby I observed that appointment the 16th day of May 2016 has the highest number of patients not showing up for their appointments, and while the 14th day of May 2016 has the lowest number with 1,049 patients. I then went on and included and analyzed and showed my findings below. And most of my findings have explained above using some explanations on each and every column. Then we go and look at the tableau. Can someone confirm for me if he or she can see my screen?
Yes, yes, it is visible.
Okay. Matter blue. I structured cards whereby it shows the minimum age, the average age, and the maximum age. Whereby I found out the maximum age, the minimum age is -1, which is an outlier. The average age is 37. The maximum age is 115. The appointment day, day number 2 of the appointment day has the highest count of patients, while day number 14 has the lowest. The patients, 65% of the patients are females, while 35% are male. 79.181 patients showed up for the appointments, while 20.19% did not show up. I then went on and visualized the patient count by neighborhood, whereby Jadim Kaburi neighborhood recorded the highest number of patients. Yeah, here I've visualized the top 10 neighborhoods. The top 10 neighborhoods according to the patient count, whereby the Bonfim neighborhood closed the top 10 uh, according to the patient count. Here I summarized my views, whereby the second day, as I have explained, the second day of Okuma has the highest patient count with 8.69 thousand patients, while the 14th day has the lowest patient count with 0.04 thousand patients. Based on gender, the female gender has the highest count of patients compared to the male gender with 65% of the total count. Most patients do show up for the appointments with 17.81% of the total count. The neighborhood with the highest count of patients is Jadin Kaburi with 19.02% of the total patient count. With that, I conclude my presentation.
Okay, thank you so much, Teddy, for your presentation. I think you have also showed a good mastery of the content from the Python section till the Tableau section. In terms of also of describing the data, where it was found and so on, I think it was good. I don't want to add so much content. Maybe Gitao, you can come in and then Fred.
Okay, so for me on my side, I can say the presentation was okay. So the code structure on Python was quite good. So everything from the start, where you had the data, to where you had your conclusions was quite okay. Then on Tableau, the visualizations are right, but I can maybe make one comment on Tableau. So you see your work, there are some parts which are hidden. Yeah, so try and ensure that the dashboard fits in one screen when presenting. So find a way in which we can be able to see like all the plots in one screen instead of like having to scroll for us to see the whole thing. Yeah, that's all.
Okay, thank you, Joseph. So I think Kitty's work is wonderful. He has done a tremendous job. So from the way he describes the data set to the way he does his exploratory data analysis, the code structures in Python, also the way he makes his conclusions, I think it's awesome. On the Tableau part, I think everything is okay. Just try fitting everything into into one screen so that we can be able to see it at a glance and be able to depict the information that you are trying to convey. So I don't have any reservations regarding your work. So maybe just to encourage you to continue doing more practice as you become an expert in it. Thank you.
Thank you so much, Gitau and Fred, and also Kate. I think he has already dropped. Maybe we can just invite Pascal to present because the next was supposed to be Matano, but I see she has dropped off. Pascal can just come in.
Okay, thank you. Good morning, everyone.
Good morning.
So I'll present to you the work that I have done. You will excuse me, my findings are on a separate document and my graphical presentations are on a separate one, but I'm hoping you'll be able to understand my work. So I will share my screen.
Okay, as you are sharing your screen, Matano, you are supposed to present, but you left, so we have given Pascal time to present, then you can come in. And we apologize for that. Yes, Pascal, you can continue.
So I hope you can see my screen. So this is my separate document for my conclusions and findings. So my heading is Getting to Know Why Brazilian Patients Miss,
Muteti, you can mute, please.
Miss Their Appointments. So I'll be taking you through a brief introduction, my analysis questions, and then I'll be moving to Tableau so I can show you the graphical representations. So missed appointments or no-shows are defined as patients who do not show up to their scheduled appointments. My data analysis aims to find out whether or not Brazilian patients show up for their appointments. Some of the reasons why patients in Brazil do not honor their appointments. This is based on the data that has been provided in the data set. And some of the methods the Brazilian healthcare providers can employ to minimize no-shows. It's also important to know that missing appointments is very disruptive, especially to healthcare providers in terms of time and money. It is therefore important for healthcare providers to mitigate no-shows in order to ensure operations efficiency. So these are some of the analysis questions I formulated that would enable me to analyze the data set that was provided. So I'll go through them. What percentage of the total appointment makes up the missed appointments? Out of the 6 selection criteria provided, this means the welfare, alcoholism, diabetes, handicap, hypertension, and communication via SMS. Which one recorded the highest number of missed appointments? What are the top 5 neighborhoods that have recorded the highest number of missed appointments? Who are the repeat offenders in the neighborhoods mentioned above? This means who are these patients who keep missing their appointments? What are the appointment scheduling trends versus missed appointments? How does age affect the nature of missed appointments? The nature being these 6 selection criteria provided, are they affected by age? And the last one, what can be done to reduce the number of missed appointments? So I'm going to head over to Tableau so I can show you my work and my findings. I hope you are able to see the screen.
Yes, I can see.
Okay, so first and foremost, with the data set provided, I wanted to know the total amount, the total number of appointments that were made by these patients, and the total number was 110,527. Then from there, we can be able to know either people honor their appointments or they miss. So based on my findings, I found that a majority of people honored their appointments. So from the total, we see 79.81% of people who honored their appointments, which is good. Out of the total of the appointments, we can see that 22,319 patients resulted in no-shows, and this is where now our data analysis comes in, because we want to know whether they are missing their appointments and the reason for missed appointments. So based on the selection criteria given, we can see that missed appointments are normally from people who are not receiving SMS notifications. So they make up 12,535 patients. We also have other factors like those with disabilities, they make up 407. Those suffering from alcoholism, 677. Diabetic patients who miss their appointments are 1,430. Those who receive welfare, 2,578, and the patients who suffer from hypertension are 3,772 who missed appointments. So we can see from this particular summary table that communication is a big factor as to why patients are missing their appointments. So based on that, I decided to check if the not receiving SMS messages and the age had to do with it. And you can see from this bar graph, I have used age bins. So we have 0 to 9 years, 10 to 19, and so forth. So I've divided the ages in age bins of 10. And you can see the more younger patients who did not receive SMSs are the ones who produce the largest number of no-shows. So this goes to tell you that maybe their guardians or their parents were not able to receive communication to bring their children to hospital, hence the large number of these age bins. So from 0 to 9, you can see it has the largest number of no-shows, which is 241 young patients. And then we can see from the bar graph that the older you get, even if you don't receive communication, the no-show is not as large as the one for younger patients. I also decided to do a side-by-side graphical representation based on the 6 selection criteria that we were provided. I wanted to see again, is age a factor when it comes to this particular selection criteria? So we have the alcoholics, the people on welfare, diabetic patients, handicapped patients, people suffering from hypertension, and those who did not receive SMSs or communication. And again, I've used age bins to put the ages in groups of 10. So we can see that communication remains the largest factor as to why patients are not attending their or honoring their appointments. Maybe this is because they are not receiving the communication, or they're not being reminded of their appointments. Then looking at age, in this age bin of 41 to 50, we can see a high number of people who suffer from hypertension are also not attending their appointments. So we can see a very high number of this age bracket, 41 to 50, who suffer from hypertension, and also this 51 to 60. We have a lot of people not showing up, and they're also not, they're also suffering from hypertension. So that's something to look at. Then we are seeing younger people who are receiving welfare, which is both a familiar. They are also not showing up to appointments. So that's also something to look at, especially at this age bracket, 21 to 30. We can see 570 who receive welfare constitute a very high number of patients not attending their appointments. So that's something to look at. So age and the well-being in terms of underlying diseases such as hypertension also has an effect on how people are attending or not attending their appointments. I also wanted to look at the trends in terms of when appointments were scheduled versus the missed appointments. And I was able to see between November of 2015 and June of 2016, they both showed the same trend. And we can see in the month of May, we had the highest number of appointments that were done, which was 67,421. And it also recorded the most number of no-shows, which was 11,769, which goes to show that maybe Brazilian healthcare systems got overwhelmed by the large influx in terms of appointments. And because we have seen that not receiving communication is the largest factor that has made people not attend their appointments, we can see maybe the influx of appointment schedules overwhelmed the healthcare system and they were not able to reach out to patients. So the healthcare providers can check the trends of appointments so that when they have a peak, they're able to communicate effectively. I also looked at the neighborhoods that recorded high number of no-shows, and we can see Jadim Kamburi had the highest number of no-shows, which is 1,465. So this pie chart just shows you the top 5 neighborhoods that recorded the highest number of missed appointments. Also, based on these neighborhoods, I wanted to see what you call repeat offenders. This means people who had more than one no-show. I classified them as repeat offenders, and you can see that they're coming from, again, the neighborhood that recorded the highest number of no-shows, which is Jadim Kamburi. So this particular patient with ID 544 and the following zeros, he or she has missed 4 appointments that they have scheduled, which is a high number. Also, again, the same neighborhood, Jadim Kamburi, we have another patient ID who has, again, missed 4 consecutive appointments. So definitely and again, if we are going to take communication as the main factor of not attending appointments, this particular neighborhood can increase their communication methods. So this is just my dashboard showing a summary of all that I have explained. So we have the trends of when we have the peak appointments and also the peak no-shows. We have the repeat offenders who are not showing up for their appointments more than once. Also, we are looking at the age versus communication, and here we've seen that parents to younger children between 0 and we can just say to 10 years need to be more communicated a bit more because they have a big number of no-shows. We also have the neighborhoods over here, which shows you the neighborhood with the highest no-shows. Of course, in terms of numbers, a lot more people are honoring their appointments, which is good. From that, we can also see a small number, which is 20%, and that 20% can be reduced. I have some maybe recommendations with regards to the conclusions that I have made. As you've noted, I haven't put gender in my analysis because I saw that everything would be inclined to the females because they're the ones who constitute a large number of appointments. So if you're going to say like repeat offenders, we have the people with the highest missed appointments, they will be female because again, they have a very high number of appointments that they've made. So I'll go back to my documentation. So for my findings, I've just summarized in this document, but it's what I've been able to present. So I have some recommendations in case, based on the data set that I have been able to analyze. So the first one is the healthcare providers in Brazil should improve on their communication channels. Like we've seen in the graphical representations, not receiving SMS constituted the highest number of no-shows, which was over 12,000 missed appointments. So apart from using SMS to remind patients of their appointments, they can also employ other methods such as emails and also phone calls, especially to guardians of younger children, because we've seen that the highest number of missed appointments is actually between the ages of 0 and 10, and these are young children. So they have guardians who normally book their appointments on their behalf. Also, the government should suspend funds from patients who are receiving welfare and are missing hospital appointments. So we've seen actually it's a younger age of between 21 to 30 years old that they have they are missing a lot of appointments, yet they are on welfare. So if there's a suspension put in place for such offenders, then we'll see a reduction on the number of missed appointments. Then also healthcare providers should look out for appointment scheduling trends. During peak months, they can increase the intensity of their communication. So we've seen that during their peak months of scheduling appointments, we also have a peak of no-shows. So that can just show that maybe the healthcare providers are overwhelmed by their appointments and they are not able to reach out to that huge number. So when they are able to know their peak periods, they're able to increase their intensity of communication. And like the first recommendation, if SMS does not suffice, they can use phone calls or emails or other forms of communication that will enable them to reach out to as many people as possible. So that was my presentation. Yeah.
Okay, thank you so much, Pastor, for that wonderful presentation. It was very clear and straight to the point. And also, I like the Tableau dashboard because you have also used some kind of images and so on. It shows some kind of expertise. Maybe just one comment. I hope you, on the Python section, I hope you share the Python work.
Unfortunately, I just did Tableau.
Okay.
Yeah.
Okay, thank you. But I hope you can be in a position to handle the same using Python.
I'm more inclined to Tableau, but I can try with Python.
Okay, yeah, because we have some kind of things that Tableau cannot do, especially when it comes to your exploratory data analysis and so on, whereby maybe you need to identify the outliers and so on. So you need to, you see, Tableau is more of a data visualization software, but Python does the rest of the work. So ensure that you do the same using Python also, especially the exploratory data analysis and so on. So I would like to invite my colleague Joseph, just say something, then Fred, as we conclude.
Okay, thank you, Xavier. So I can say that Pascali, your approach is unique. So from your presentation, I got to see some quite some few different things from what we've heard in other presentations. So first of all, you presented on the business problem before even going to the research questions. Then you went on to the research questions, and finally you went to the conclusions and the recommendations, which we haven't seen in most of the presentation. So a big up on that. Then your Tableau dashboard visualizations were detailed, so we could easily understand what you were doing, and those presentations were able to answer the questions that you had presented. Yes, so on the programming part, on the Python part, I would advise you try, even if it's not learning everything on Python. I know not everyone is a programmer. So on Python, simply learn how to handle the data cleaning part. That only. Since you are already perfect on Tableau, once you've cleaned your data in Python, just save it as a CSV file, then proceed on to visualization in Tableau. Yeah, that's all.
Okay, thank you, Joseph, for the comment. So, for Pascal, actually, I like the approach that you took. So, I can say it was somehow unique to the previous presentations that we've had. So, you really defined the problem very well. So, also your presentations on Tableau were also great. So, the only thing to focus on is on Python part because, as my colleagues have said, that sometimes Tableau cannot do everything. So having hands on a programming software like Python can help in other data analytics tasks. Yeah, so I think you should just check on that. Otherwise, I really liked your work and the way you are presenting the composure and the confidence also was somehow perfect. Thank you so much.
Okay, thank you, Fred and Gitau. Maybe Pascal, you can say the last thing before we usher in Matano to close for us with her presentation.
Okay, thank you so much for giving me the time to present. I received the comments. I will look into Python so that I can see where I can be able to reach in terms of the analysis. But I enjoyed the classes. I enjoyed, as you can see, I was more inclined to Tableau because I enjoyed that class a bit more. I'll look into Python and see what I can do, then I'll send that work.
Okay, thank you so much, Pascal. We can now welcome Azana to present.
Hello, everyone. Good morning.
Hello, good morning.
Yeah, my name is Matano Azana.
And before you present, I really apologize. I thought you are a she, I really apologize for that, but you can proceed.
No problem.
Yes, you can proceed by sharing your screen.
I have shared. Hope you can see my screen.
Yes, I can see, but you can now share the content that you. Yeah. Okay. Thank you. Yes, Matano. I can't hear you, though I can see your screen.
Hello.
Hello. Hello.
I'm sorry for that. I had some internet issues, but hope you can see what is on my screen.
Yes. Yes.
Yeah. So for the first step, I had to import the libraries that I was going to use to do the data visualization and exploratory data analysis. And the libraries, as you can see, are the ones over there: pandas, numpy, matplotlib, seaborn. The next step was to import my data and save it under the we saved it under the variable df. So I proceeded the and called top the top five variables in my data, which are so that I can explore and confirm whether it's okay. And my data contains patient ID, appointment ID, gender, schedule ID, and so on. So I proceeded to my exploratory data analysis to confirm, to check for the data for any missing values and any any inconsistencies in the data. I was able to figure out that there are 110,527 columns, 110,527 rows, and 14 columns. There are no missing values in the data, and my data mainly consisted of floats and objects and integers. So there is no issue on that part. And I proceeded to check my columns, which range from patient ID, appointment ID, gender, schedule day, appointment day, age, neighborhood, scholarship, hypertension, diabetes, alcoholism, handcuff, SMS received, and no show. I proceeded to check for the summary of the data. Upon checking out for the summary of the data, I realized that there was an inconsistency somewhere where we have an age, a minimum age of -1. That is nonsensical and which doesn't make sense to me. So I consider that as an outlier. So I decided to drop it. I had to check whether there were any other outliers, and from the age column, and amongst each and every column I couldn't find another outlier, so I decided to drop the missing data. I decided to drop the outlier. So my data shaped therefore changed from 110,527 to 110,526, as you can see. So the shape changed from 110,527 to 110,526. So I proceeded to, I checked for the summary again, and here, as you can realize that the minimum age has changed to from -1 to 0, since it doesn't make sense to me that there is someone aged -1, so that must have been outlier. I proceeded to checking for the top 5 patients, and the data was unchanged at that bit. So at that point, when I was satisfied with my data that I had done enough cleaning, I proceeded to the data analysis. The first bit was to find, I plotted a histogram to show the attendance irrespective of any other characteristics. So the histogram, as it shows, there is a pretty big discrepancy between the no-shows and the shows, those who decided to show. As you can see, those who decided to show are greater, as displayed by the histogram, as compared to those who failed to show. So my next question I asked was, what is the average age in the different neighborhoods? And I calculated, for example, in Aeroporto, the average age was 53.12, and some neighborhoods like Paka Industrial was 17, and I had sorted the data according to, in descending order. The neighborhood which they had the highest average age was Elhas Oceanicas de Trinidad. These are all neighborhoods in Brazil, and as you can see, we have 81 of them different neighborhoods. So as if we were to arrange the neighborhoods according to their average age, the ones with the lowest average age will be Parque Industrial and Sao Benedito. I proceeded to check for the awarding of scholarship because, as per the research data, there is a non-governmental organization which was providing family aid to families in Brazil to counter hunger and such. But the scholarship was contingent upon some of the conditions they deemed fit. And some of the conditions were, the organization had to make sure whether a family's children had to be vaccinated so that they could be awarded with a scholarship. So when checking the awarding of the scholarship, how many of them had scholarships and how many of them did not have the scholarships, you can see those with the scholarships were 99,665, while those without were 10,861. I proceeded to check the correlation between the diseases, and the correlation between hypertension and diabetes is at 0.433085, while the correlation between alcoholism and handicap was 0.004674. So there is a slight correlation among the diseases, but not a very big, it's not as major as we'd expect. So the next step was to do a visual representation of the genders and the attendance to the appointment as made. As you can see, there is as we had expected, expected. The genders, there is the majority are female and the lesser and the minority are male, but there is a consistency with the inconsistencies, as the proportion of the in attendance to attendance among the female is the same as the proportion of those who fail to attend from the males. As you can see, the figures are similar, although their sizes are quite different. When I proceeded to check for the count plot of the no-show, the next question was, does the sending of the message affect the attendance of an appointment? So the visual representation I used was a count plot, and those who received a message and decided to show, and those who did not receive a message and decided to show. As you can see, there is also a similarity, as those who did not receive some message, they have the same proportion of them attended as illustrated down here. Those who received a message are 62,509 and decided to show, while there are some who received a message yet decide not to turn up, which are 12,535. And there are those who did not receive a message, which are 25,698, but decided to show, and others which did not receive a message completely and henceforth they did not turn up, which are 9,784. So the proportion here is not different amongst the two groups, those who received the message and those who did not receive the message. So I did a scatter plot to see whether there is a correlation between receiving a message and turning up. And as the scatter plot shows, there is no discernible relationship between the two, as those, whether a person received a message and whether they did not receive a message, we cannot plot a scatter plot to show any relationship between them. The next factor I investigated was alcoholism. Does alcoholism affect one's keeping of an appointment? So as the graph shows, alcoholism did not, those without alcoholism, those who without alcoholism and decided to show were 85,524, and those without alcoholism and decided not to show were 21,642. Those with alcoholism and yet showed up for 26,883. Those with alcoholism and did not show was 6,777. So the proportions here between the two are not very different, as you can calculate. I did the calculations on a Word document elsewhere. So that document is not responding. Please let me proceed.
Yes, just proceed.
The next thing I decided to investigate was hypertension. Does hypertension affect keeping of an appointment? As the figure shows, this is a count plot of hypertension. Those with hypertension and decided to show, and those without hypertension and decided to show. So those without hypertension and decided to show were, as you can see, the figures shows this one, they are here, and those with hypertension decided to show here, there, here they are. Those with hypertension, those without hypertension I did not show. They can be illustrated. When you check the scatter plot, there is no discernible relationship between hypertension and attendance, as the figure shows. The scatter plot below, the scatter plot on your screens shows that there is no relationship between hypertension and showing up. So the numbers for the hypertension, those without hypertension and decided to turn up was 70,178, while those without hypertension and did not turn up were 18,547, while those with hypertension and turned up for the appointment were 18,029, while those with hypertension and did not turn up were 3,772. So the next stage was I had to check I grouped the data set as per their neighborhood, as per their respective neighborhoods, and checked for the alcoholism counts. Which neighborhood had the highest values of alcoholism and which ones had low values of alcoholism. And you can see Andorinas, majority there, they do not drink, they do not suffer from alcoholism, as they assign their binary value 0, which is 2210. The next stage was I investigated whether an awarding of a scholarship, does it affect the keeping of an appointment? Does it provide the incentive for one to keep up the appointment? As we can see that the appointment has some conditions for one to be awarded an appointment. So does the scholarship provide them with the incentive to turn up for the appointment? As you can see here, the scatter plot shows there is no correlation between those turning up with with the scholarship. We cannot plot any correlationship using our scatter plot here. As you can see, the numbers for those who turned up with their respective awarding of scholarship or failure of. So I concluded that the provision of scholarship or lack thereof does not provide an incentive for one to fulfill the appointment as set on the scheduled date. The next stage was to check for their handicap. As you can see, there are different handicap levels, level 0, 1, 2, 3, 4, and their attendance, whether they attended the appointment or they failed to attend. As you can see, it's consistent for all the levels of handicap, that whether one had handicap or did not have handicap, the proportion of those which attended was always greater. So we cannot conclude that their handicap was the hindering factor that kept them from attending the appointment. However, for those with higher levels of handicap, as you can see, level 3 and 4, there may be a slight improvement in the there may be a slight improvement in those in attendance, in that as the handicap increased, the proportion of those who attended decreased. But when we plot a scatter plot, we cannot find any correlation. So if there is any correlation between the two, it may be quite small. I proceeded to my Tableau dashboard. Yeah, as you can see on the dashboard, the youngest patient is aged 0 because I decided to drop the outlier which was aged -1, and the average age of all the patients was 37.09, and the oldest patient is aged 115. The diabetes turn up. There were among the patients with diabetes, those who turned up were 88,207, while those who did not turn up were 22,309. While the neighborhoods with the highest alcoholism, as it can be attested, Jardin Kamburi had the highest turnout with 77.17. That's the neighborhood with the highest case of alcoholism. This is not about turnout. This is about the number of alcoholism in the neighborhoods where we have Jardim Kamburi has the highest case of people suffering from alcoholism. And when I checked for the pie diagram when I checked for a pie chart for the entire population, as expected, the majority were female with the proportion of 65%, while males were at 5%. But for the turn up, those who failed to turn up were 27.57%. 27.57% decided not to show up, while 72% turned up for the appointments. When we check for the hypertension cases by gender, we can see that the proportion for the males and the females is quite similar. It may not be the same, but it's similar, as those who did not turn up were 7,725, while those males who turned up for the appointments were 30,962, while the females who did not turn up were 57,245, while the females who failed to turn up were 14,594. And when we checked for their neighborhoods, the attendance per neighborhood, we wanted to check which neighborhood had the in attendance or attendance respectively. And you can see the data is consistent with Jadim Kamburi at the highest attendance with 62,502, had the highest population, and with the highest population had the highest attendance of 62,502, while at the same time it had the highest in attendance with 1,465, while the other neighborhoods which had which had the top population were Itarare, Jardim Kamburi, Jardim da Peña, Maria Ortiz, Resistencia. So in conclusion, I concluded that the patients, though diverse, had similar traits in the different groups. Most of the patients, as could be expected, were female, but the difference is not as the big difference as the difference of those who showed and those which failed to show. However, the proportion of failure to attend is consistent with both genders, with females at the end of my presentation.
Okay, thank you so much, Azana, for that wonderful presentation. Just to start, you show the description of data. You are able to identify the outliers and address them accordingly. And also coming to W, you are able to present quite well. Maybe just the comment I have when in terms of now communication, sometimes you took a lot of time maybe to how can I put it, to present a point. It means what that means is that you haven't reviewed very well several times or prepared very well in your presentation. So I can advise on that, whenever you go to present, ensure you practice first, so that when you are presenting, there's just a flow of words, a continuous flow of words, uh, and so on. But I'm very impressed with the work that you've done. I want to invite Joseph to give his comments, then Fred, then we can conclude.
Okay, thank you, Xavier. So for Matano, I think the presentation was okay, except for the part that Xavier has mentioned. So when preparing for a presentation, make sure you revisit and like summarize what you are going to present so that you won't be taking much time in presenting your points. So the rest of the presentation was okay. On the code part, everything was fine, and also the Tableau dashboard. So for the Tableau dashboard, just as we had commented earlier, so make sure everything fits under one screen so we can see everything in one screen. Yeah, so that's all.
Okay, thank you, Joseph, for the comments. So I believe my colleagues have added their comments on what you need to improve on, just on the communication part. But otherwise, I liked your presentation, your approach on which you are exploring your data, identifying missing values and outliers and so forth. So that was quite wonderful. However, I had some reservation on when you were doing some sort of correlation, because I believe that you had some categorical variables, and whenever you try to do a scatter plot of categorical variables, it may not actually bring that correlation. So I believe you should maybe try maybe other other techniques for categorical variables. Like for example, for categorical variables, we normally do a chi-square and identify if there's actually a correlation, as that is not the same for continuous variable. So I think that is why you are not seeing some sort of correlations in your variables. So I think that is something also that you should. That is what I noted, but the rest of the presentation was quite okay. So that is it from my end. Thank you so much for the presentation. Back to you, Xavier.
Okay, thank you, Fred. Maybe my thought, do you have anything as we close?
Thank you for your guidance, and I appreciate highly. And it was a wonderful session. It was good knowing you and the team.
Okay. Thank you so much, Azana. We will communicate by email with our comments. Thank you also, Gitau and Fred, for making your time. Actually, this session is recorded. We'll be uploading in our YouTube channel or wherever, and share with you guys maybe to review later. Thank you all. Have a nice afternoon.
Likewise.